All right, number 16, we have a rational equation here. So this is a rational function or a rational equation where we have a polynomial in the numerator and or denominator, right? And remember, in reciprocal, we just had an x to the first power in the denominator and really no other x's in the mix. And so here's a case where we have a polynomial, and oftentimes you'll have them in the numerator and the denominator, right? So multiple x's and lots of things roaming around. And so there are some similarities between reciprocals and rational functions, and you can consider a reciprocal function a subset of a rational function. But anyway, so there's a little more variety to a rational function. And if you watch video 31, you'll see some more depth with this. But when the degree of the numerator is the same as the degree of the denominator, your horizontal asymptote is going to be the ratio of the leading coefficient in the numerator over the leading coefficient in the denominator. And so here the leading coefficient is 1. In the denominator, the leading coefficient is -2. And so we're going to have a horizontal asymptote at -1/2, right? So it's just 1 divided by -2 is -1/2, right? And so that's going to be our horizontal asymptote. So y equals -1/2 is going to go through right there, right? Okay. All right, now a vertical asymptote is going to happen where the denominator equals 0. And so what we want to do with the rational function is really factor as much as we can in the numerator and the denominator. So I'm going to do that. So I'm going to factor. Let me move this out of the way. So I'm going to factor the numerator and the denominator. So the numerator has x as a common factor, right? So then it'd be x squared minus 7x plus 12, right? And so then I'm going to have x, and then I'm going to factor out this inside value here. So I'm looking for numbers I can multiply to get 12 that I can add to get 7. So that'll be 3 and 4. So 3 and 4. And then this tells me that the sign of the bigger number is negative, and this tells me that the signs are going to be the same, right? So they'll both be negative. Then on the bottom, I'm going to factor out a -2. Let me do it over here first. So it'll be -2, and then x is common as well. So this will be 1x squared positive minus 1x, and then minus 2, right? Okay, so I'm going to set it up in a similar way. And so if I factor this out, I'm looking for numbers I can multiply to get 2 that I can subtract to get 1, right? So that would be 2 and 1. And again, this tells me the sign of the bigger number, so the 2 will be negative. And then this tells me that the signs are different, so that means that the 1 will be positive. Okay? All right. So wherever the denominator equals 0, you could potentially have an asymptote, right? So the difference is when you have something that matches up in the numerator and denominator, like that x, that's actually going to be a hole. Okay, so it talks about holes. So we're going to have a hole at x equals 0 because if I set x equal to 0, or if I even, let's say I set -2x equal to 0, right, this whole factor, then that would turn into x equals 0. So that would be a 0 that a 0 in the denominator, so it's going to be undefined there. But since the top cancels out, it's still going to be undefined, but it's going to be a hole instead of an asymptote. Okay, so x equals 0, there's going to be a hole. All right, and then let's see. And then, yeah, we know about horizontal asymptotes, right? We got that taken care of. And then let's see, the other zeros in the denominator will be at x equals 2, right? There's no other x equals 2, or there's no x minus 2 on top. So that is going to be a vertical asymptote, okay? So x equals 2. So that's going to go right here. And I'll just write it right here below x equals 2. And then the other asymptote is going to be at x equals -1, right? And I get that from here. So basically whatever values for x will create a 0 in the denominator are going to be where your vertical asymptotes happen. So I have another one here. As long as they don't cancel out with anything on top. When they do cancel out, that's when your holes will happen, right? So those are all the undefined values, is here, here, and here. All right, 2 of them are asymptotes, and one of them is a hole. All right. So now, let's see what else. Yeah, x-intercepts. So that would be where the function equals 0, and that's going to be where basically we can have a 0 in the numerator, okay? And we know 0, this doesn't count because we have a hole there, but we can solve for these. So our x-intercepts will be x equals 3 and x equals 4, okay? So x equals 3 and x equals 4. All right, and then the next thing you can do, and this is kind of a part that is a little bit of a guessing game sometimes, but positive would be here, and then it would kind of usually alternate. Like this would be if it were a positive function, but since we have a negative leading coefficient out there in the front, it's going to be upside down, so it'll be something like this. So I'm going to come up along this asymptote here. I'm going to go through, and then it kind of goes through here, and then it's going to kind of go towards that asymptote. So it does cross that invisible boundary, but on this other side, what's going to happen is it's going to go this way because we don't have any intercepts on that side, right? So it's just going to do that, and in the middle here, it's going to kind of come down and it's going to we have a hole at 0, right? So let's see, it's going to be somewhere around right here, and then it's going to kind of do something like that, okay? Once again, it doesn't have to be perfect, but yeah, and you can graph this on your graphing calculator too and kind of check it, but make sure that you show all the work to find all these values, okay? So I don't mind if you graph on your graphing calculator to kind of shape it out a little bit, because once again, it's a little bit of a guessing game, without like really checking a bunch of different points. But yeah, but you can use your calculator to shape it out, and then just remember that we have a hole at x equals 0, so that's on the y-axis. So wherever it crosses the y-axis, you're going to have a hole right there. Make sure you put that on the graph. And your graphing calculator won't show you that hole, so make sure you have that. Your graphing calculator also may or may not clearly show you where the asymptotes are. So that's another thing that, show your work to get those. And domain, so domain is going to be basically x cannot equal any of these things, right? So x cannot equal 0, x cannot equal 2, and x cannot equal -1, right? Because those are the zeros in the denominator. And then the range, now the range is a little different. It looks like there's a few, there's some area in here where the range doesn't actually equal, but and it actually does cross -0.5. So yeah, for the range, we're just gonna put a question mark here for the range. So just really give me the domain in these ones. Yeah, actually, it doesn't even ask for the range. So these are really hard to find the range for. Like you'd have to do some really deep investigating, or find the value here on your calculator and the maximum value here. And anyway, so we're not going to be dealing with the range on these ones, okay?